Welcome to Physics Made Easy channel. And the next topic that we shall do in this lecture is NOR gate, and then we shall proceed to exclusive OR gate. First, what is NOR gate? NOR gate is a combination of OR gate and NOT gate. Now, in this symbol, this is the symbol of this particular is the symbol of, you can say, OR gate. This A and B is the input. A is input, and then we have got B is input. This A is input, and then B is input, and here we get output. Output is just according to our operation y is equal to A plus B, and then we take not of this. This is not operation. We take not of this, and we get final output here. Y is equal to A plus B naught. And if I apply De Morgan's theorem here, then we get A bar dot B bar. Now this ORing operation has been changed into ANDing operation. And this is the basic symbol. This is OR gate, and this bubble. Bubble, remember this bubble has to be empty. This has to be empty, and also we can draw circuit in this form. Now if I attempt to draw circuit like this, it's very easy. For example, I will take here two inputs like this, and we will take not of these two inputs. I redraw this because diagram is not good. So what we shall do? We will just draw these two lines, and then I will show here a gap, and then here we shall be having an AND gate. An AND gate like this. So this is also the representation of same gate. Now here is the input with dark bubbles. These are the input terminal A and B. And here I apply NOT operation represented by this single bubble. Now the input here will be A bar, and here input will be B bar, and here the output will be A bar dot B bar. This is another implementation of NOR gate. This is another implementation of NOR gate. This is the implementation of NOR gate by using OR gate. This is the implementation of NOR gate by using AND gate. You should be familiar with both of these. And now let us do the truth table for OR gate. 0 plus 0. If we they're ORing, or if we add them, we get 0. And now we will take reverse of this, which will be 1. NOT operation converts 0 into 1, and then 1 and 0 gives us 1. NOT operation converts it into 0, and then in the next case we have got A input is 0, B input is 1, and here we get 1 by ORing. This is by plus operation we get 1, and this is the final output, which is 0. Reverse of this, again 1 and 1, it gives us 1 and again 0. It means the output is 1 if and only if all the inputs are 0. In NOR gate, output is 1 if and only if all the inputs are 0, and it is 0 otherwise. Now here they have shown it through a practical implementation by making use of NOR gate. So as we have already done, this circuit is common emitter amplifier. This much of the circuit is common emitter amplifier. Common emitter amplifier or common emitter transistor, it introduces a phase difference of 180 degree and it acts as a NOT circuit. And this part is basically a diode implementation of OR gate. If I take this part is, I will take it in broken lines. This part is, here it has been clearly written, this is OR gate. This part is OR gate and this part is NOT gate. Now, the next operation that we shall discuss is exclusive OR gate. Now, exclusive OR gate can be obtained by OR and NOT gates. This is the logical symbol of exclusive OR gate. This is OR gate with this additional separating line. Note this symbol of exclusive OR. This is simply an OR gate and this is exclusive line. Additional line to the OR gate which makes it exclusive OR. This is the mathematical symbol y is equal to a b bar and a bar b. This is its mathematical symbol. And then we have got another another Boolean expression for this circle having a cross inside it. So in this case, we have got a circle having a cross inside it. So the expression for this is y is equal to a bar b plus a b bar. Now the logical symbol of the truth table, corresponding truth table, you fill the value 0 and 0. If you fill a and b both 0, a equal to 0 will make this 0 and the b will make this 0. So both the factors will be 0, their ORing will give us 0. Now if one is 1 and the other is 0, in this case, this is 1. So the first factor, so how we will reach at this result is first a is 1, b is 0, 0 bar plus a bar 1 bar into 0. Now this gives us 1, 0 bar 1 plus 1 bar 0 into 0. This becomes 1. On the same line, if this is 0 and this is 1, now it is the b which is 1 and a is 0. In this case, if I solve y like this, first is b is 0, b is 1, a is 0. So first is 0. A is 0 and b is 1. So this is a b bar. A is here and b is here. Plus, now, in the second case, a bar is 0 bar. 0 bar into 1. And this will come out to be 0 plus 1. So this is 1 here. And if both of them are 1, then it will become 0. Now you should check it yourself. So what it means that the output is 1 if the inputs are mutually exclusive. One input is 1 and the other is 0. And the output is 0. See, in this case, both the inputs are same, output is 0. Both the inputs are same, output is 0. Output is non-zero when the inputs are different. That's why we call it as exclusive OR gate. Now this is the circuit implementation of exclusive OR gate. I will just show how this came out to be. This is A, input went here. So A is fed to ending circuit. This is B and here we get B bar. So B bar is fed to this circuit and this multiplication took place here and we got A B bar here. Here, from here we get B and A here, A, its bar is taken, A bar, this is A bar B and this is AB bar. Now here we have these two inputs, A bar B and AB bar input. Here the input is AB bar and here the input is A bar B. Now we add both of them. Y is equal to AB bar plus A bar B. This is what we got. The next is exclusive NOR gate. In case of exclusive NOR gate, it is just exclusive OR gate. We just take its NOT operation here. Or mathematically what we write is Y is equal to AB bar plus A bar B, and here is bar of this whole. So in this way, 0 and 0, its output was 0 in previous case and now it will become 1. And here it was 1, it has become 0, it was 1, it is 0, and it was 0 and now it's 1. So what is important is in previous circuit the output was 1 when inputs were not identical. In this case output is 1 when inputs are identical. Note it down. In exclusive OR gate output was 1. This is 1 and this is 1 and inputs are not identical here. Note it down. Output is 1 for this segment. In this segment's inputs are not identical and output is 1. When inputs are identical, output is 0. Now in this case, note down in this table, when the inputs are mutually exclusive, output is 1, it is reverse of above. And when the inputs are mutually exclusive, output is 0. When the inputs are equal or identical, then the output is 1. So these two circuits, they give opposite results because of the NOT operation. Now this is the practical implementation. This is the practical implementation of these two gates. A is the input. A is here, B, and here we took NOT of this, and here we got B bar, and here the output is AB bar. Again, here we got A bar, and here the input is B, and the final outcome that we got is A bar B. And in this case, note down, this is a NOR gate. In exclusive OR, it was OR gate. There was no bubble. In exclusive OR, it was OR gate. Now, here, it is NOR gate. NOR gate means the output here will be A bar B plus AB bar and this. NAND and the NOR gates are as universal gates. The repeated use of OR and NAND and NOT gates alone cannot give different gates. But the repeated use of NAND gates can alone give us all the OR and NOT gates. So we call these two gates NAND gate, and these gates, they are universal gate. In digital circuits, these gates serve the digital building block. This is a very important question. Note down this line. 1 mark question, or it's good for your knowledge. NAND, they are universal gate. Universal means all other gates, they can be derived from NAND and NOR gates. So with this, we have only one topic left in this chapter. So this chapter of logical gates is very paying from examination point of view and from competition point of view. And I request all of you to practice the numericals corresponding to it, particularly numericals in which we convert the numbers and then we derive the waveforms. You are given input A and input B, then you have to draw a waveform for the output. This kind of question is usually asked in your board examination in as well as in your NEET examination. So with these words, before finishing this lecture, I request all of you to kindly comment, share, and like this lecture. Thank you.